Okay.
Hello everyone, welcome to today's webinar, Flexible BIM Workflow with Rhino, VisualARQ and Grasshopper. You will see an overview of how to work with parametric architectural objects, how to produce 2D drawing from the 3D model, how to generate dynamic BIM objects driven by Grasshopper, how to automate many modeling tasks through the VisualARQ components built for Grasshopper, how to add custom data to geometry, and listing schedules, and finally, how to deliver BIM models and collaborate with other tools through the IFC import-export capabilities. So a webinar packed with content. Today's webinar presenter, Francesc Salla, is an architect graduated in 2008 and joined Asuni in 2010. Francesc is the product manager of VisualARQ and Lens Design, the two main products of Asuni. Now, let me tell you a little bit about Novedge. Novedge is changing the way designers purchase 3D software. We offer more choices, more freedom, best advice, faster service, and most importantly, no headaches. Check us out at novedge.com. And this is actually the VisualARQ product page, and you can click it and see all the specification. As you can see, we have great price. And for more daily software news and promotions, you can always find us on Facebook, Instagram, Twitter, you name it. And I want to remind everybody that today's webinar will be recorded and you can watch it again on our YouTube and Vimeo channel. Just search for Novedge. Now, without further ado, I'm going to allow Francesc to show and share his screen. Take it away, Francesc.
Okay. There we go.
Yes.
Thank you very much, Barbara. I'm very excited to be here and show you the last stuff that we have been working for VisualARQ. And for those that don't know the tool yet, I would like to show you an overview of the main features. Okay, we talk about VisualARQ, about a tool, about software that adds flexible BIM features to Rhino. And I will talk about what does it mean, what this concept of flexible BIM means. So on one hand, we all know about BIM, okay, basically the idea to manage everything from the 3D model. And VisualARQ adds some features, some BIM features to Rhino that we will see during this webinar. So basically, first of all, VisualARQ has tools to generate all the documentation from the 3D model. Okay, that means all the plan views, section views, schedule tables. Okay, and everything is managed from that 3D model. Also, VisualARQ provides a set of architectural objects. Okay, that they are parametric and they are associative, and they fit into the Rhino NURBS geometry. So you can create like curtain walls from NURBS. You can insert doors in them, as well as you can insert in walls, and they are associative. Okay, so they generate the opening automatically, and later on we can edit the features of these objects parametrically, which provides a very easy way to work with parametric objects and model very quickly the projects of architecture. Also, VisualARQ provides the option to change models from Rhino to other programs in the AEC industry through IFC. And since VisualARQ has also these architectural objects, when they are exported to IFC, other programs like Solibri, Revit, ArchiCAD can read these objects as their own ones, okay, with some exceptions that we will see later on. But basically, all the data and all the parametric objects can be kept from one program to another. And when we talk about this flexible BIM, first of all, we talk about this idea that is the opposite of some programs that work with BIM that have this problem that BIM, you need to work with one specific window, you need to create all straight walls. And since VisualARQ works on top of Rhino, which is one of the most capable programs to work with organic shapes, so you can work with any kind of design, okay? And well, you can take, for example, one piece of freeform shape like this polysurface, and add information on it. For example, we can tell this piece of polysurface that is a slab. So we can tag with a specific IFC category called slab, IFC slab. And after that, when we export that geometry to IFC, other programs will understand it as a floor or as a slab. Okay. And in addition, you can also generate like custom parameters, for example, a manufacturer, a cost, material, and also add data for these parameters to any piece of geometry. All right. That, by the way, they will be stored as IFC properties when we export this geometry to IFC. Also, VisualARQ connects with Grasshopper in two different ways. So on one hand, all the visual objects are available inside the Grasshopper, and this lets you automate workflows, as we will see later on with a few examples. Okay, so for example, in this picture that you see in the screenshot, from one volume, we generate some section lines, some contours, and rather than using just extrusions, we use VisualARQ slabs that are already BIM objects. Okay. So basically, the idea is to have, well, there are some components to generate new objects that require some information, okay? And there are some other components that are used to deconstruct the information of these objects. That way, we can, for example, deconstruct a wall and obtain the height, the alignment, the volume, all its data, okay? And we can connect these components with other add-ons for Grasshopper for other operations, okay? That can combine with other tools. Also, VisualARQ provides this other integration with Grasshopper that lets you generate objects from Grasshopper definitions. Okay, you will see later on that some of the standard VisualARQ objects are very simple in terms of level of detail, but with this integration, you can generate your custom dynamic blocks as a Grasshopper definitions and import them as new objects in VisualARQ. Okay, we'll see some examples of this workflow, but basically the idea is that well, we could define this in 3 steps. So on one hand, we have here the Grasshopper definition, pure Grasshopper components that generate these objects. So there are some sliders that control the, you know, the dimensions of the object. And here there is the dialog from where you can create a new door from that Grasshopper file. Okay, we'll see that later on in detail, but you basically define how you want to edit this object, and later on you can insert this object into the scene. Okay, so once this object, this new style is created, you can just insert it as any other door in this case that you have in the document, and you can edit the parameters that you had in the Grasshopper definition from the VisualARQ dialogs. Okay, we'll see another example more quietly later on. Okay, so well, this integration lets you have with one single Grasshopper definition, like unlimited objects in the scene that are using different dimensions. Okay, so basically having custom dynamic blocks. Actually, in Food for Rhino, there is a section where you can find objects that people are loading. Okay, you can find a few of them, and of course, if you know Grasshopper, I encourage you to upload yours and share them with the people, with everyone. All right. So they are full parametric custom objects. Okay, driven by Grasshopper. Now I would like to highlight one of the most important features of VisualARQ. One of them is the option to print the model, the 3D geometry, directly to vector output. Okay, you may know that when we have, for example, this piece of geometry, the Rhino logo, and we are using the shaded display mode. I mean, we can actually activate here a section, but when we are using shaded modes, we can only print that as a raster, because otherwise we see all the wires, all the edges of the whole geometry. But VisualARQ provides this hidden display mode, okay, that lets you print whatever you have in the scene directly to vector output. Okay, that means that we can print a very good quality to the line just by using this vector output. We will see this how applies to architectural projects later on, but is really a useful tool for generating 2D drawings. Another important feature is these navigation tools, the level manager, that lets you work at different elevations, okay, and also lets you show and hide levels as if we had clipping planes. Also, it provides this cut plane function that when we see the objects from the top viewport, we see a 2D representation of them, okay. In the same way, VisualARQ provides this section manager that also lets you well, manage the different section lines that, by the way, they can be jogged, as we can see here, okay. We can switch one or another just for working or for visualization purposes, okay. Also, with one button, we can align a section view directly to the viewport, so in the way that it's ready for printing, okay. Also, VisualARQ adds some objects that can have like different 2D representations according to the 3D or the plan view representation. They can use blocks, okay, or they can be defined as Grasshopper definitions, as we have seen before. And here there are some other interesting tools. For example, since VisualARQ are blocks, they need their own commands to do, for example, Boolean operations. So in this case, if we want to subtract that solid from a stair and keep the parametric properties of the stair, VisualARQ requires its own command to do this operation, this Boolean difference. Okay, but all time keeping the parametric features of this stair object. Also, well, since the last version, we have added some some roof intersections and beam intersections. Okay, or we have improved the IFC import and export features. And we have provided a way to collaborate with the team through external references support. Okay, so basically you have a master model where you can insert parts of that project where that other people in the team are working. Okay, and just refresh this part as you would do it with any other Rhino block. It is important that when you insert the block, it is embedded and linked. Okay, in order that the VisualARQ objects are displayed properly in the master model. Now I would like to show you some user cases based on 3 different ways people use VisualARQ. Okay, in the first group, I will put the people that use VisualARQ for quickly modeling the projects in 3D using the VisualARQ objects. Okay, like this example of Bionics, which is a church in Croatia, in Solin. Okay, that is made out of VisualARQ objects. Also Rhino geometry, of course. In the model, in one model, there are always a geometry of any sort. But allowing to create this project with VisualARQ objects, with parametric objects, helped a lot in the development of this project. Okay, and I would include in this group people that need to do visualization. Okay, to quickly build up the 3D model, sign materials, and shot renders. In the second group, well, before going to the second group, VisualARQ is also used for well, building up a project from a 3D point scan. Okay, so like this example of this lighthouse, where well, the architect needed to deliver a BIM model, and they from a point cloud they generated all this project with VisualARQ objects. Okay, and they had also the plans already done. In the second group, I would put the people that use VisualARQ for producing 2D drawings, okay? And they don't need to necessarily work with VisualARQ objects. For example, in this project, all the geometry that you can see here are just Rhino solids or polysurfaces and surfaces. So just by assigning like section attributes, line weights, and using the VisualARQ tools to generate section and plan views, this architect just generated all the 2D drawings with VisualARQ. And this use goes from architectural projects to projects of other scale, like this mailbox designed by Alan Gomez, that also uses VisualARQ for generating the sections and plans of this piece of geometry. Okay. Finally, in the third group of VisualARQ users, I will put everyone that is interested to exchange Rhino models with other programs through IFC. Okay, they assign data to geometry, they tag it with a specific category, and finally they send the model through IFC, so they can deliver BIM models, or they can exchange it with other professionals. Okay. Just some development facts. VisualARQ, well, we provide free updates, okay, for existing users. People that had VisualARQ 1 can upgrade to VisualARQ 2 for free, okay, and there are commercial versions and educational versions that follow the same policy as Rhino educational versions, okay, so that means that academic files can be exchanged with commercial versions, or they can be used for professional purposes, okay. And at the website, there is a 30 trial day version available. But if anyone is interested to have more time to test VisualARQ, feel free to write us at any of these emails, okay, for asking for an extension. All right, so I will just show you now VisualARQ live. Okay, some of the main features that we have been talking about in this presentation. And well, I would like to start with the an overview of the VisualARQ toolbar. Okay, so as we can see here, there are the main VisualARQ toolbars. First provides all these objects that we were talking about. Okay, some of them have like additional tools to do certain operations, like creating walls from curves or from solids. Okay, or extend them to surfaces. Then we have these edit tools. Okay, for doing Boolean operations, or for flipping the direction of certain objects, as well as splitting or filleting them. Okay, and then there are some documentation tools. Okay, like for example those for creating plan or section views. Okay, in a similar way as make2d command does, or for calculating areas, generating list of the information that we have in the 3D geometry. Okay, adding tags. Okay, or this one that opens the level and section manager. Okay, that we have already opened here. Finally, we have some additional tools. Okay, for example, commands to select objects by its type. Okay, we can select all walls, for example, in that model just with one command. Or there are other tools to check the object properties, or create new parameters. Okay, by document in this case, or create custom profiles also that we can use on openings, beams, columns. Okay. All right, let me put this up there. And let's start with the navigation tools, the level manager. Okay, that lets us work at different levels in one project. So in this case, we have 4 levels. Okay, that has each one has a construction plane at specific elevation. Okay, so we can quickly switch from one level to another, and as you can see here through the grid, this construction plane moves to any position. So anything we draw now will be created on that elevation. While if we switch to the ground floor, now everything will be created on top of this construction plane. Okay, as long as, of course, that we don't snap on points of other elevations, and we have the project snap on. Also, imagine that on top of each level and the bottom of each level, we had clipping planes. So when we switch some level off, we actually are activating this clipping plane. Okay, located in this case at this elevation, and it clips everything above this elevation. Okay, and that makes it easier to hide levels and see what's inside, work from the inside. Okay, of this project. For example, we can move this door. Okay, and makes it easier to work with architectural projects inside Rhino, no matter if you are working with visual objects or not. Okay, this is really helpful for any kind of geometry you have in the scene. Also, when we activate one level, we can activate when we select one level, for example, the first floor, we can activate this cut plane. Okay, that moves this clipping plane at certain distance and defined by this value, which is basically a value that cuts through all the doors and windows. And when we do this from the top viewport, so let's go to the top viewport, do double click here, which actually hides everything upwards automatically. When we activate this cut plane, we see a 2D representation of the objects. Okay, so we can basically work here in 2D, but in fact, we are editing the 3D model. Okay, we can put this back to plan view with that button. Okay. Also, we can switch from one level to another just by doing double click and very easily just navigate through the project at different levels. Okay. So back to the perspective view, we can switch everything on, back, and we can see also the section manager. So this is similar than level manager, but lets you manage the section lines. In this model, we have already 3. If we select them and toggle this dynamic section, we can see their position, okay, and just move this section line at different positions. Or if we just switch the section line, okay, we see the model sectioned according to the other sections. Okay, from here we can also create new sections with this command, or also with this command that we have over here at the VisualARQ documentation toolbar. And these section lines can be jogged, as we will see now. So we basically define one section style. Okay, I will just disable the OSNAPs 1 second, and we can just draw. Let me check the construction plane. I will just work on the ground floor. Okay, so we'll just repeat this command again, and we can just define the points of this section as if we were drawing a polyline. Then we need to define like a viewer position and a depth. Okay, and finally a text, like let's call this section D. Now back to the section manager, we can activate this section D and see the model section it according to these control points. Okay, which by the way, they have some control points that let us see the area of the objects that are inside this section line control. Okay, that means that only objects inside it will appear. Okay, we can actually draw something at any other position. Okay, and well, as you can see, only the part that is inside is clicked. Also, as you can see here, the VisualARQ objects have like a 2D representation. For example, walls have this hatch pattern. Okay, and same as well these walls over here and some other objects. Okay, this can be managed through the VisualARQ object styles. Okay, styles in VisualARQ are what define the object features. But in case of Rhino geometry, okay, there is also the option. For example, let's switch to the section C and move this section C next to some object that is a Rhino polysurface. For example, this ramp, if we check its properties, we see that this is a closed solid. Okay, so imagine that we wanted also to add some hatch pattern for this piece of geometry. So when you select it, you can go to the properties. Under this section icon here, we find all the section attributes available for Rhino geometry. So we can assign, for example, a single hatch pattern. Okay, we can change the scale or the angle. Okay, we also see this this object in section with specific attributes. So basically, we could assign section attributes to the entire model, even if we have it's made out of Rhino geometry, and get like all the section attributes when we generate the drawings. Okay. Actually, well, if we take a look at the level and section manager, we can see here some additional buttons that let us align, for example, a section view or a plan view to specific detail or specific viewport. So let's switch this off and let's move to the page layout. Okay, so imagine that we had the page layout with a couple of details in here. Okay, and we wanted to show in one detail the section C. So we can click inside the detail, select section C, and click this button to automatically align the viewport to that section C. Okay, and we can do the same in this other detail with section B, for example. Okay, and the same thing goes for 3D views. 3D views, okay, that can be sectioned here, or floor plans. Okay, we have here a couple of details also. We click inside one detail, and from the level manager, we can just double click on the level we want to display. Okay, and for example, we can show the terrace floor here and the ground floor here. If we had this in 3D or in other viewport, or also we were using a different display mode, okay, just by selecting this floor and clicking this button, we will align also activate the plan view on the on this detail, and the display mode will switch to hidden, which is the one that we need to print directly this view to vector output. Okay, of course we should adjust the scale later on by run the detailed properties. But basically this is ready for printing. Okay, we can make a quick test. Okay, just print this. We will choose vector output, the printer and paper size, and print this to see the result. Okay. Of course, the quality of the output matters, of the printer quality, and also the scale of the object that you are showing. Okay, so let's see. This is plans, floor plans. Okay, and we will do another test also with the 3D view, because this applies to not only 3D objects but also 3D views. Okay, and basically here what we will do is to add some hatch pattern to the slabs. Okay, so I will just move back to the model. I will select one slab, and we will go to the styles dialog of this object. Okay, which is something that you can go from here. If we do right click on this icon, and we can assign some, well, here's where we define the features of the slab. So if we expand this style, we can see the list of layers. We can add more layers here, but if we select the layer, we can change, for example, the thickness or the attributes. So we can assign also a single hatch pattern, okay, with the same scale as the other one, and pattern angle, okay. And when we click OK, all the slabs that have the same style will update. Now back to the 3D view. Okay, if we take a closer look, we can see that all the slabs are taking this hatch pattern. Okay, so we will have always the last version of the model in these page layouts, since they show the real model in section, in plan view, in 3D. So we can now just print this view as well. Okay, since we are using the hidden display mode inside, this is ready for printing to vector output. Okay, so click on the print button, and we'll save this to PDF. Okay, let's wait for the save dialog, and we will see. We'll call this 3D view. There we go. Now I will just show how this 3D view looks like. Okay, what is the result? And as you can see, we get like good quality to the line vector output. Okay, of course, as closer as we get, the lines may not be accurate, but we need to take into account that this is a A3 paper size. Okay, and well, very tiny details represent a very tiny, well, small areas in the paper. Okay, but the quality is quite good already. We can also see the other file that we created, the floors. Okay, so also we can see here the quality of the 2D drawing. Okay, that goes directly to vector output. All right, let's close this and let's see how to work a little bit with visual objects. Okay, of course, I don't go through all of them because well, I don't have time for this, but I just want you to have the idea how they work. Okay, what is the basic workflow? So when we run a command, actually we can work from the top viewport. Okay, on that ground floor, we just define some insert options. Okay, for example, in this case, we can select one style. Okay, for generic 90 millimeters, define some height by default, or the alignment. Okay, so we can click on this button and add here a piece of wall. Okay, and same works with the rest of objects. If we need to insert here a door or a window, we need to define one door style. Okay, some dimensions by default. For For example, here, this hinged simple has already some predefined sizes. We can always pick other, okay, and type here any other value, okay, or define how we want to show it in plan or in section view, okay, in plan or in 3D. So in this case, I will show it 50% open. Here I need to define the opening position, and the door generates automatically the void inside the wall. Okay, it will get attached to this wall as long as it finds the wall path. Okay, if we move it outside of this door, of this wall, it won't generate the opening. Okay, as soon as it goes closer to it, it generates it. Well, all the visual objects also can be edited through control points. For example, when we select these objects and activate the control points, we can stretch, for example, this room, okay, or we can stretch a wall in one direction with using these control points, or for example, we can change the door opening side just dragging this control point next to the door leaves. Okay. Also, we take a look at these walls in 3D. They have like an extension arrow that let us modify, the height of the wall, okay, by pulling it. Later on, we can select the object and edit it through its properties. So when we select this wall and go to the properties panel, we can see there is this wall icon and change, for example, the style to any other style, or we can change, for example, the height to 1 meter, for example, in this case. Okay, so that's the advantage of working with parametric objects. And as I was mentioning before, some of them can be created from curves. So for example, all these railings that you can see here were created from path curves, and we can see how it works here with a wall. Let me just get rid of this. We have here, for example, a wall, and if we draw like a line that goes like this, okay, we can either generate a wall from a curve. So we'll select this curve that generates like a new wall. Or what we can do also is tell this wall to change its path. So one of the properties of the wall is this path curve. So we can click on this icon and select this path curve. Okay. Now we just need to select the control points of these other walls and extend them, okay, to meet the other wall. All right. Well, as you can see, the door oriented automatically to the wall path, and it will go. They will do it this way as long as it finds the wall path. Okay. If we move it outside, it will keep floating in the scene. All right. Okay. Let's move on. If we take a closer look at the visual objects, okay, we can see that the level of detail of them it's not so accurate. Okay, they are very simple in terms of representation, but as I was mentioning before, they can be created from Grasshopper definitions. For example, in case of walls, if we take a look at this wall style, let's open all the wall styles. We get a list here of all the styles available. Okay, and we can, for example, generate. We can duplicate an existing style. Okay, and for this one, we can we can call this generic 100 millimeters. Okay, and let's call this generic 100 millimeters 3 layers. And we can add 2 more layers on it. Okay, so we just do right click, select new, and add new layer. Okay, if we click on this button, we will be able to see this in 2D. Okay, in plan view, and I can move this layer just between the other ones. Okay, and assign, for example, a hatch pattern for this, like a solid hatch pattern for this layer. Okay, let's call this solid, and this other layer. Okay, like a solid hatch pattern. And finally, we can change the thickness. So we can assign here like a 1 centimeter thickness to first layer, and same for the other layer. Okay. And well, this tells me the total thickness of the layer, so we can make this middle one, okay, like 2 centimeters thicker. Okay, so basically, just by editing the features of each one of the components of the wall, okay, in this case wall styles, we can customize our library of walls, right? So now we click OK, and I can select this wall, for example, that we have been working on, go to the properties of the wall, and change it for the new one we have created. Okay, as you can see, we have all the 2D representation updated, right? In case of doors, windows, okay, and other objects, there is the option to, for example, let's go to door styles. There is the option, for example, we can take this hinged simple and assign a 3D block for the 3D representation of that door. Okay, that lets you well have a custom object or maybe a block that you have found in the web to be used as a 3D representation of this door. Okay, and also you can use a 2D block that you have created for the plan view representation. Okay, and then you have them as much detailed as you want. But of course, a block is not parametric. So what if we could create this from a Grasshopper definition that it's fully parametric? So let's see an example of how this works. So I will now open Grasshopper. And well, this is a definition, okay, that generates this well, defaulting door. Okay, so just ignore all the wires and mess that it's here in the middle. I just want you to take a look at these sliders that define, you know, the shape of this defaulting door. So we have the height and width on one hand, okay, and we have some other parameters that control the thickness of the frame, the aperture, okay, of this door, as you can see here, alignment, number of leaves, okay, we can change it to 4, and other parameters that I created in this definition in order that how detailed I wanted it to be, on which features I wanted to edit on it. So we have these input parameters on one way, and on the other way, on the other direction, we have ending geometry components, okay, that collect the different parts of this assembly of this door. So we have one component that collects all the geometry for the leaves, okay, another geometry param, okay, that collects all the glasses, and another one for the frame. Okay, it is important to rename this component the way you want, in order that later on you can recognize it as the part that you want it to be. Okay, and I also have another component, which is the geometry param, that collects the profile that can be used for generating the opening of this door in a wall. Okay. Also, another thing to take into account is that this geometry, if you want to use it as a door or as a window, must be aligned along the x-axis and must have the middle bottom point located in the 0 coordinates. Okay, these are the two main things to take into account when you create custom definitions for visual objects. Okay, for doors and windows. Now we can save this file. Okay, we close it. And we go back to the door styles. I do right click on this icon to open the door styles dialog. Okay, I can just run the new, I can click on this new button, which gives me two options. So I will select this Grasshopper style option, and I will select now this file that we have just saved. We click next. So we go through this wizard to generate a new style. And well, we can see here, well, the style name, okay, default door. Let's name it like this, the definition units. And also we can choose one of the components as the opening profile. Okay, so we'll choose that curve that we had in the definition. If you choose the auto option, which in this case would already work, the bounding box of the geometry is calculated according to generate the opening into the wall. Okay, but since we had it already, we can select this component. So now we have the other remaining components that we had as ending, geometry params. So we have the leaves, the frame, and glasses. And we could also have additional components for the 2D representation of this door, okay, which we should assign it to the plan representation here, okay. If we don't have any one of these checkbox marked, the plan view representation of this geometry will be the real cut of this object, okay, according to the cut plane height of the level where they are located. Now, here we get all the list of inputs, okay, the sliders or lists that we had in the definition, and we can decide how we want to edit them. For example, the aperture is something that we want to edit by object individually. Okay, we can also change the type, so we can define it as a percentage. Same as height, width, or number of leaves. We can assign this by object. Okay, the rest of the parameters can be edited by style. That means that we'll change all the doors, okay, that we had in the scene. Or we can also hide some parameter. For example, if we don't want to anyone to edit the leaf type, okay, we can set it by definition. Okay, so no one will be able to change this, okay, without, of course, running this wizard again. All right, actually, if you do right click on this option, on this style, you can run the edit, which goes through the wizard again. I mean, you can reload the same definition if you have done changes on it. So we'll read the changes and you can redefine the style from the same definition, okay? So we have now this bifolding door as just another VisualARQ object, VisualARQ door, where we can expand this triangle and we can see the different components, okay, that we have here. And therefore we can assign a specific attribute. For example, in case of glasses, I can assign material glass, okay? I can actually put it in the same glass and the same layer where the glasses, the components of other objects are located. Actually, the material will be then set by layer. Okay, so we can just remove this window, for example. Okay, we will work on the first floor, run the door command, select this bifold door, and insert that door in this wall. Okay, once this is created, we can go to the properties, check the door parameters, and here we can edit those values that were left editable by object. So we can make this window door actually wider. We can change the aperture, okay, to 80%, for example. All right, or we can change the number of leaves to 6. Okay, so with this workflow, we have like custom parametric objects that, by the way, can be used on any of these objects that you can see here, except walls and curtain walls, which is something that is planned for future versions. Okay, if you take a look at the furniture styles that come along with VisualARQ templates, okay, you will see already a number of objects like this cabinet, chair, double beds, okay, sofas that are all created from Grasshopper definitions. Okay, or also some interesting objects can be found for annotation, this annotation object. For example, if we run the annotation command, okay, we can use this elevation mark style that is basically an object that detects a reference point, okay, and shows the elevation of it. So this is basically an elevation mark that is using a Grasshopper definition in the background. If we change its position in the z-axis, it shows the current level elevation. Okay, so we can have many of them, and as long as we move in another position, it will show the elevation of this point. So also with this Grasshopper workflow, you can create your custom objects, not only for 3D objects, but also for annotation objects. Well, we have been talking about 3D objects, also these annotation objects. Let's see more tools about the documentation commands. Well, we have seen how to generate like floor plans and section views, okay, using this hidden display mode. But actually, if you needed to export this section or plan views to DWG, there is a specific command that lets you do it. So this is a command, section view command, similar to make 2D, but it, well, we select one section view style, we select one section line, for example, the section C, and we can insert, let's insert in the ground floor, a section view according to that section line selected. Okay, it will generate a 2D drawing of that section of the, well, a section view of that project. Okay, this is actually a block. Okay, but as long as we explode it, we will get all the 2D lines. If we don't explode it, it will keep, you know, the link to the 3D model. That means that we can move an object somewhere else. Okay, for example, we can move it. We can make a copy of this tree. Okay, and as long, of course, that this tree is inside the sectioned area, we can just update this to the drawing. Okay, that will calculate all the changes that have been done in the 3D model. All right. So this is particularly useful if you need to export that to DWG. Okay. Well, there are some issues with this tree we have in the background. Okay. But well, this is useful for exporting that to DWG or exploding this object and work with the resulting 2D lines. More about documentation. We have been talking about that working with visual objects provides, you know, working with geometry with information. But what if you wanted to create your custom parameters? Okay, imagine that we want to define like a manufacturer or unit cost for all these elements. So there are different ways to do this. We can do it by object individually. We can do it by object style in case of visual objects, or just we can create new document parameters. So we'll be able to assign them for any piece of geometry. Okay, so with this icon here, we open the document properties. Here we can add a new parameter, for example, unit cost. Okay, assign to a specific category, like general, and the data type. That will be a number. Okay, actually a currency. And click OK. And now when we click OK, we can, for example, select this B folder, go to the properties, and under this parameters icon, we can assign here a value for the unit cost. Okay, like 300. Okay, and we can do this not only for visual objects, but also for Rhino geometry. So for example, if we had this ramp was kind of object that we want to give a value, we can see that this is a closed poly surface, and we can also assign like a value for this ramp, which, by the way, when we export this object to IFC, will be stored as an IFC property. Okay, and this brings me to well, to explain that, as I was showing the presentation, you can tag any piece of object with a specific IFC category. In case of this, let's say, poly surface, we can go here to the IFC tag and assign a specific category, for example, an IFC ramp. Okay. Now I would like to talk about the other way VisualARQ connects with Grasshopper. We have seen that, well, when we run a Grasshopper, okay, we could create custom objects from Grasshopper definitions, but we can also create visual objects from them. Okay, for example, if we want to create a wall, we have this wall component that requires a path curve, so we can draw a curve, reference it here, and connect it to the wall path. Okay, if we need more options, we can connect a wall path. Okay, sorry, a wall options component, and here with a numeric value, assign a specific height. All right, and so on. We can create new styles. We can define all the components. All the components for generating new styles and new objects are available here. And showing some more complex example, okay, we can go here and select this definition that generates this, you see, this domain structure. We can define here the number of of rows and columns of this structure, okay? And this is basically a definition that uses slabs, stairs, and columns. Okay, we can also change the number of levels and have a full, structure that are using BIM objects. So as long as we bake them, we will work with, we will have VisualARQ objects ready, ready to be used here, as if we had created in the sim. Okay. Right. I would like to show you another example in another project. Okay, of how these Grasshopper components can help you to automate processes. So, for example, we have seen how to create a section. Okay, a section view. But what if we wanted to create all the elevations, the 4 elevations of this kitchen, okay, at once? So first, we can insert here a space. So we run the space command, click a point inside this kitchen. Okay, a space needs to find like walls or objects tagged as spaces, as a line that I have over here, to detect an enclosed area. So let's call this kitchen. Okay, and now we can open Grasshopper. Okay, I will show here the bifocals and add a definition that generates section views from reference space. So this definition, basically, I can reference one VisualARQ space. Okay, this definition finds the boundaries of this space. Okay, by deconstructing it. Okay, so I can get all the surface and all the edges around it. And just with this value, I can define the separation of these section lines, okay, from this boundary. And I just need to define some insert points for my section views. So I click on one point, and if we see the end of this definition, we can see a section line of the list of section lines that we have got here, and the section views with the insert points. Now, if we select both components and bake them, okay, we'll get at once the 4 elevations of that space generated in the sim. Okay, so we wait a few seconds that it finishes, and we close Grasshopper. We see the 4 section views here generated. All right, which, by the way, again, they are linked to the section lines. If we move it, if we added new stuff, we should select them and update them. Okay. Another example that we can do with the Grasshopper components. In this case, imagine that you would like to quantify the volume of storage of these furnishing elements. So here we have objects that, if we take a look at them, like this kitchen cabinet, they have some depth, height, and width. Okay. So first of all, we will open the document parameters, and we'll create a new component, a new parameter called storage volume. Okay, we can put this here under the geometry and select as a type a volume. Click OK, and now I can select one of these objects. For example, this. Go to the parameters and assign here a value. Okay, you don't want to do this manually, of course. So what I will do is open Grasshopper. I will open a definition that, I will just ignore this, where I can reference a few furniture objects. So I will just select all these furnishing elements that I have got here. Okay, I click enter, and then I can get with this component, that is actually a component that you can find in here. Okay, the get property. We can get the width, depth, and height of each one of these objects. So just by multiplying them, I can get the list of all the volumes that I want to list. So there are different components that we can use to assign a value to an object. We can use this set property. So we should select here the list of objects. Okay, the list of properties would be well, the parameter that we have read with this component that reads all the existing document parameters in this document. Okay, so we should connect this here, and the value will be this list of values that we have generated. Of course, if we baked this component, we will get duplicated copies of the furnishing elements, and we don't want that. So rather than using this component, I will use this update property, which does the same thing, but will only bake that information for the specific on these objects. So we have the list of objects on one hand, the properties this one, the document parameter storage volume, and the values the same as we did before. We update this property, and now we can close Grasshopper, and we select this object. We see here already the volume assigned for each one of them. Okay. Finally, we just need to list it. So we go to the documentation tools. I do right click to generate a style, a table of styles. We have already some existing styles for listing this kind of objects. For example, we can run here the openings table and list the information of all the openings that we have in the model. But we can do the same for the furniture. So we can, create a new table from this wizard, or we can just select one of them, duplicate it, and work on the copy. So I will call this furniture kitchen. Okay. Just notice that here under the types, we can decide which kind of object we want to display. We want to quantify, and we can do it for any kind of geometry in the model. Okay, polysurfaces, blocks, visual objects, whatever. So I will just select here furniture, and if I expand this, here I can see the list of parameters that I want to show. So in case of the quantity, this groups the list by a specific category. So we'll just uncheck this. And now I will go to the height, because this height was referred to the column's height. Here, if I want to show the height of these furnishing elements, I need to tell this that this applies to furniture of any style, and the height, actually, I need to specify each one of the styles, because each style for these furnishing elements is created from a Grasshopper definition. So they have their own parameter called height. So I will select the cabinet here and select here the proper parameter called height, and do the same thing with the other furnishing styles that I had in the scene. Okay, and finally I can select the kitchen cabinet. There we go. Select height again. Okay, and now finally with this volume, I will select here furniture of any style, and in this case I will select this storage volume that we created before. We click OK. We run the table command, select furniture, kitchen, and I can just now select these components. Sorry, these styles, these object styles, to insert the list of objects with a corresponding volume. Okay. If I want to see the total sum of this volume, I can just go to the styles. Maybe we will just create a duplicated copy of this table style. And what we will do is to group, here under quantity, we can group, we can group this table according to one common parameter. In this case, it's something that we need to add, because the rest of parameters are different, okay? And we won't be able to do it. So what I will do is here, change this parameter by type. Okay. So we'll select, rather than style, we will select type, and here under the quantity, for the type, we will group all the objects of the same type. Okay. Now we can make a copy of this. Sorry, a copy of this table. Okay, and I will select it and change the style to total volume. Okay, I get the total volume. Well, here I needed, there was one object that didn't have volume, which is the cabinet. I think it's this object that for some reason, maybe I didn't select it in the Grasshopper. So we'll just put, any value here. Since these tables are linked to the 3D geometry, okay, I can just update them, okay, and they will show me the last information added, okay. And here I can see finally the total volume of storage that I have in this building. I would like to end with seeing the IFC export options. Okay, so we have seen in this model that for example, for this polysurface, we have tagged it, as a ramp. Okay, we can also have we have also assigned a unit cost, and we can see how this model works when we export it to IFC and we open it in Revit. So we'll go to File, Save As. We just need to select the IFC file format. Okay, so we'll save it in the desktop. I can now move to Revit, go to File, Open, IFC, and I will select this file. I take a breath while Revit opens the file.
A well-deserved breath, Francesc, this webinar. That was a marathon. That was so much information. That's great.
I know you will need to pause the video a few times to.
That's great. That's the way we like that.
Follow up everything.
Thank you.
Next time we should schedule a 2-hour webinar, I think at least.
Fine with me. Fine with me.
I don't know, but I'm almost done. Okay.
No worries. No worries. We're still very much engaged.
Actually, while this model opens, I can just show how, for example, how VisualARQ opens an IFC file. So we can go here to File, and I will just will go to my documents where I have some files in IFC, and we can see how, for example, VisualARQ opens an IFC file generated by Revit and how it reads all the all the geometry. So, for example, this one is this is a sample model that Revit provides exported to IFC, and for example, we can see that all the information of levels, okay, is read here, all right. Or if we take a look at any object, for example, this one, this is actually a railing in Revit that has been read in VisualARQ as a block, okay, with a corresponding IFC type. As I was mentioning at the beginning, some objects are not identified with the objects that they are among AC programs, okay, like Revit, ArchiCAD, or VisualARQ. This happens with many of them, but not for railings, stairs, and curtain walls, mostly. But if we take a look at all the objects, all the VisualARQ objects that have been identified, okay, we can see that there are many of them. And some association, for example, the opening of this window inside the wall is also kept. Or if we take a look at the properties of this window, okay, we can see that there are many of them that are read. We can read them from Grasshopper here. We can list them. We can keep on working with them. And if we send that model back to IFC, they will also be stored in the IFC file. Okay, let's see that model in Revit. Okay, if we take a look at at this file, for example, we take a look at just a regular column, we can see that the translation has worked very well. We can change this column. We can edit the type. We have here the full options as a Revit column. And this also works with, for example, a wall, okay, that has a straight path like this one. We can change it for any other type in Revit. But if we take a look at, for example, the wall that, for example, this wall that actually follows a north path, we don't see any editable option because Revit doesn't recognize originally how was the geometry that generated this wall. But let's take a look at this ramp. Okay, actually it was a polysurface in Rhino but as you can see, Revit recognizes it as a ramp. If we go to the edit type, we can see, well, there is the unit cost that is missing here. Well, this is something that should be fixed, should be revised, because the custom data on objects should be recognized here, okay, which is not, didn't work in this particular object. If we go to the edit type, okay, we can see, well, that all the features of this default door, actually they were the features of the, you know, the Grasshopper definition. They are all read in here. Okay, number of leaves, aperture, and so on. All right, so I close this. And well, I think that's pretty much what I wanted to show. I hope you enjoyed the webinar. If you have some questions, maybe we can have like 5 minutes, 5-10 minutes for a few questions if you want. So
Thank you, Francesc. I enjoyed it very much. There's not many questions, but a lot of comments on how great this webinar was. And the only question is if you would be able to share the Grasshopper script. Or
yes, no problem about that.
I
can share it to anyone.
Okay, how do we?
You can just send me an email. I mean, I think the easiest thing is that you send me an email. Okay. Anyone interested can just send me an email to the, well, you know that here at the VisualARQ website.
Great.
You go to support, and you just send an email here, and I will share that definition. I mean, the one that generates the opening, the elevations, I guess.
Yes, and actually questions are popping up now. Are the default doors in the Revit model still parametric from
no.
No?
They are not. They are recognized as doors, but they don't have the same parametric features than in VisualARQ. Okay. They're like custom parameters that are read as, you know, as, let's say, static information.
Cool.
Okay, we have all these values like, you know, like static data. So changing this value won't change the frame width, for example.
Got you. And when we make a render in Rhino, will we get then a realistic render? Well,
same as Rhino. I mean, visual objects are Rhino geometry, in fact. Okay, so when we shot a render, it is the same as if we had pure Rhino geometry. Actually, here this is a Rhino surface that has already a texture on it.
Yeah.
But yeah, it's actually the same.
All right. Okay. And there's a question about the link between visual objects and GH. For example, the workflow for optimization processes. Grasshopper.
Well, as we have seen, some visual objects can be generated with Grasshopper definitions, for example, for this domino structure. Okay, so they can be generated in Grasshopper, so it is easier to build them at once. I don't know if this answers the question.
We'll see. We'll leave a few seconds. Let us know. And if you don't mind, since that was the last question, in the meantime, I will take my screen back so I can show you exactly. First of all, I want to thank you for attending. I can show you where you can find VisualARQ on the Novedge website. And of course, you know, we also sell Rhino at a great discount price. And there's another question, actually. Are you aware of a way of producing a watertight outer shell as a BREP or mesh object around the objects that comprise the building?
I guess it's, for example, if we wanted to create like a shell for this domino structure, for example, I guess. Well, I mean, This is up to the user. I mean, they can use curtain walls for that. Okay, so we could run the curtain wall command for example.
Okay. Okay, cool. And so somebody just asked a question about the price of VisualARQ and asking if that's a 1-year rental or if it's a license. And I believe that is the price of a single license. And it's not a rental, it's yours if you want to keep it forever and ever. Okay. Again, I want to thank you for joining us today. I want to let you know that we are everywhere on social media, so you can find us there for latest release, future webinars, new products, information. And I'm reminding you that I've been recording this webinar, so you will find it as early as this afternoon on our YouTube and Vimeo channel. Thanks again, Francesc, for today's incredible marathon, and looking forward for another webinar. Have a great rest of the day or night. Bye-bye, everybody.
Thank you. See you soon.
Bye.
Bye.